Hey there, let's geek out some more about exponents and roots. And today we're going to look at rationalizing denominators. Okay, so as we kind of covered in class, remember that whenever we have a denominator of 0, that's bad. That's undefined, right? We have no idea what the denominator is here because a fraction, the top number, the numerator, represents the part that we're interested in, and the bottom number or denominator represents the whole thing. So how can you have a part of something when there is no whole thing? That is undefined. Okay, and doesn't matter what the numerator is. This could be any number or variable or exponent or crazy expression. If it's over a denominator of 0, it is undefined. So the same idea kind of applies when we have an irrational number. So if we have like the square root of 3, remember the square root of 3 is a non-terminating decimal. That's going to go on forever and ever and not end. So that really doesn't make sense either. How could we have a part of a whole thing that clearly kind of doesn't make any sense? It's a non-terminating decimal that goes on forever. So what we want to do is we want to rationalize our denominators. So if we come into a situation where we have an irrational number in the denominator, like root 3 right here, we want to multiply it by some number so that we end up with just a nice number that makes sense, a rational number. And that's where the term comes from, rationalizing a denominator. We're looking at the denominator and we're making it make sense. So what we do generally, the play, we have the square root of 3 and we're going to multiply it by whatever this is as a fraction with itself. So square root of 3 is right here. I'm going to multiply it by the square root of 3 divided by the square root of 3. And remember, anything divided by itself always equals 1. 3 divided by 3 equals 1. The square root of 3 divided by the square root of 3 equals 1. Jordan divided by Jordan equals 1, right? Anything divided by itself equals 1. So when I multiply this expression by 1, I'm not really changing the value of the expression. It's still correct. I'm just writing it in a way now that is rational. Okay? So whatever the denominator is, if it's an irrational number, multiply that by itself over itself as a fraction. Now let's just multiply it out. We have 1 times square root 3, which is square root 3. And down here, we have the square root of 3 times the square root of 3, and that equals the square root of 9. Because we have two numbers that are underneath the square root sign, we have two radicants, if you will, we can multiply those two numbers together and still leave it underneath the radical sign. Okay, so 3 times 3 is 9, and I can just write it like this. And the square root of 9 is 3. Let's take the square root of that, the principal square root, and we'll express it as so. So instead of the square root of 3 divided by the square root of 9, let's write it as the square root of 3 over 3. And now, my friends, this is rationalized. We have a denominator, 3, that makes sense. 3 is 3, all right? So that's great. We don't really care about the numerator so much. So this is a rationalized denominator. Let's take a look at a few more examples. Here we have 15 over the root of 6. Again, root 6 is in the bottom here, so let's multiply by root 6 over root 6. Multiply the top, 15 times root 6. We just write it as 15 root 6. We just express it all together. And on the bottom we have root 6 times root 6, which is the square root of 36, which simplifies to 6. Now keep this in mind as well. My math lab always wants you to reduce your fractions. Fractions should be in lowest terms. So root 6 over 6, we can't really do anything with that. They're two different numbers. This is a rational number, this is an irrational number. But get in the habit of kind of looking at the rational numbers here and just reducing that if you can, 15 and 6. So we can divide both of those numbers by 3 to reduce them. 15 divided by 3 is 5, 6 divided by 3 is 2. So now this little fraction here is reduced, and this is rationalized and in simplest form, which is a great thing. Now keep in mind, another example here, we have 12 over root 8. You don't always have to multiply the root by itself. You could just multiply it by whatever number you need to, such that we get a perfect square. 16 is a perfect square, okay? If you did multiply this by root 8 over root 8, you're not wrong. You're still going to get the right answer. You just might have to do a little bit more reducing at this step. Okay, that's it. So if you really want to speed this up and do less dividing at the end and reducing, just multiply it by some other number to get a perfect square. So here I'm going to multiply it by root 2 over root 2 because I know 8 times 2 is 16 and 16 is a perfect square. On the top, 12 times root 2 is 12 root 2. we can express the root of 16 as 4, and then we can just simplify our fraction here. 12 divided by 4 comes out to a whole number. So this is 3 root 2, and this is rationalized. All right, now let's take a look at what happens when we have a really complicated thing going on in the denominator. And this brings into the idea conjugates. All right, so a conjugate, I'll explain that in a sec, but this applies to situations where we have two terms underneath in the denominator. So we have 3 root 2 minus 4. Again, this is an irrational number. 4 is fine, but again, we're going to have to rationalize this. So a conjugate is the exact same thing as what's written in the denominator. The only difference is the sign is flipped. Okay? So if we look down here, I just typed it down again. The conjugate of 3 root 2 minus 4 is 3 root 2 plus 4. So when you have two terms, write them again. Just flip the sign in between them. That's what a conjugate is. And a conjugate is some number that when we multiply all this together, we'll get a rational number. All right? And it might look a little complicated, but just follow me. So here, 3 root 2 minus 4, we're going to multiply it by 3 root 2 plus 4, again, as a fraction with itself, because this still only equals 1, even though it's complicated and scary looking. Now we're going to multiply 8 times 3 root 2 plus 4. I'm going to use brackets here, 8, and then I'm just going to put that conjugate in brackets. And down here what's going to happen is we're really kind of foiling it. You'll get into the FOIL method. Check it out as well, like if you want more information. Khan Academy does a great video on this. There's a ton of videos on foiling things on YouTube. But essentially, we have 3 root 2 times 3 root 2. So I'm just going to write that as 3 root 2 squared, right? Anything times itself is squared. And then we have 4 minus 4 times 4, which I'm going to write as minus 4 squared. Remember, a negative times a positive is always a negative. And 4 times 4, I'm just going to write that as 4 squared. Okay? Oh, sorry. So let's continue now. We're going to distribute on the top. So we have 8 times 3 root 2. Well, we can only multiply the real part of this number, or the rational part. So 3 times 8 is 24. I'm leaving the root 2. I'm not touching that. I can't multiply a rational and an irrational number. But then 4 times 8 is 32. Don't forget to distribute to that second term. And then down here, interestingly enough, 3 root 2 squared, well, remember each term, not a term, but each little part of this is going to get squared. So that's like saying 3 squared times root 2 squared. All right? So 3 squared is 9, and 9 times root 2 squared, well, the root and the square cancel, so that's just 2. 9 times 2 is 18. That's how I came up with the 18 right there. Minus 4 squared is going to be minus 16. 4 times 4 is 16. So that's cool. What we can do now, we can evaluate this. 18 minus 16 is 2, and then again, we just look at our little fractions here. And remember, in this case now, we have a binomial on the top. We have two terms, two numbers separated by an addition sign, so each of them have to be reduced separately. All right? So 24 divided by 2 is 12. I keep the root 2. That's going to be 12 root 2. And then 32 divided by 2 is 16. So now this is reduced. We have 12 root 2 plus 16. And this is rationalized as well. Okay, so a lot of complicated math, but just break it down. Remember, we're always multiplying it by the same thing with a different sign. Let's take a look at some examples now. We have 7 root 6, so let's multiply that by root 6 over root 6. Right? Same thing, what's going on here? That's going to be 7 root 6 on the top over root 36. And that's going to be 7 root 6 over 6. And again, 7 over 6 is already in lowest terms, so that's our answer. We're done. This guy over here, let's multiply him just by 2, by root 2 over root 2. Right? Because I just want to get to the next perfect square, and I know 18 times 2 is 36. So on the bottom, I have the square root of 36, which is a perfect square. On the top, we have 7 root 2, and that's going to be 7 root 2 over 6. Again, same answer as before, but it's rationalized. Now let's do a little more complicated one. We have a binomial on the bottom, so let's multiply this by the conjugate. So that's going to be 3 root 2 minus 5. Remember, the conjugate is just a different sign. Same thing, so 3 root 2 minus 5. Let's multiply this guy out. This is going to be, I'll write it using brackets. 3 root 2 minus 5. And down below here, this is going to be 3 root 2 squared minus 5 squared. Remember, it's always going to be minus 5 because it's a different sign, right? It's always the opposite sign, so we're always going to have a negative second term down here. Numerator, let's distribute. 2 times 3 is 6, so it's going to be 6 root 2 minus 10. Remember the second term, 2 times minus 5 is minus 10. And down here now, we're going to have 3 squared, which is 9, times 2, which is going to be 18, minus 25. 5 squared is 25. I'm going to rewrite this again. 6 root 2 minus 10. And down here we're going to have, what's this, minus 7 as our denominator. Again, rationalize, that's great, we're done, but now just make sure that we're in lowest terms. And in fact, actually, we already are. 6 and 7 is in lowest terms, and negative 10 and negative 7 are in lowest terms already. So there we go. Rationalized. Okay, I hope that helps. If you have any questions, don't hesitate to let me know. Thanks.